Hello guys and welcome to today's class. For today's class, we'll be looking at the solution to experiment 1 on chemistry practical manual. Topic is measurement, and the aim of this experiment is to familiarize you with some of the equipment and practice measurements using metric systems. So for this experiment, we'll be looking at the measurement of some metric systems such as volume, weight, etc. So we start with the first one there, the measurement of volume. In this experiment, we'll be measuring volume using three apparatus there, which includes the small beaker, the large beaker, and then the small conical flask. All right. So between these three apparatus to measure volume in the lab. Now, from what we have there, you'll be given a small beaker of volume 60 milliliter, a large beaker of volume 60 milliliter, and then a small conical flask of volume 75 milliliter. All right, so these are the original volumes of the apparatus you have there. All right, and then you'll be asked to measure the volume of these beakers 3 times. For the first time, from this table here, you can see that the first measurement gave us 59 milliliter, the second gave us 58 milliliter for the small beaker, and the third measurement gave us 59 milliliter. All right. As you can see, also notice that I did not add milliliter there, and the reason is because the volume is already indicated here, as you can see here, as milliliter. So I don't have to start writing 60 milliliter again. It's not necessary. Also, for the large beaker there, the original volume or the true volume there is 60, of course, a milliliter there. When I measured first, I got 58 milliliter. I measured the second time, I got 59 milliliter. And I measured the third time, I got 58 milliliter. So I had these three there. Finally, it was now time for the small conical flask. For the small conical flask, the original volume there was 75 milliliter. I measured first, I got 73 milliliter. I measured again, I got 74 milliliter. I measured the third time and I got 73 milliliter. Alright, so these are my results from my measurements. Now we asked to fill this part here, fill the column of the mean, that's this column here, and also the column of the percentage error. Alright, so let's look at how to fill the mean and percentage error for each of them. First things first, let's start with the mean. So let's start with mean. Let's fill the mean. So let's start with the mean. So mean. Let's start with the first one there. Let's start with the mean for the small beaker. Alright, so the mean for the small beaker is simply equal to, now to get mean, it's as easy as you start from 1. So this is my small beaker here. I'll take this value on under 1, 2, and 3, and I'll add them up. So it becomes the value of 1, which is 59. So for mine, it becomes equal to 59. So I'm having 59 plus the second thing there was 58. So I'm having 58 plus the third one there was this 59 you have here. So I'm having 59. So I'm having 59 plus 58 plus 59 all divided by, for this one here, I did my measurement 3 times, 1, 2, 3. So it becomes divided by 3. And that's equal to, I write down my value. Okay, so if I add 59 plus 58 plus 59, I'll get 176. That becomes 176 all over 3. And that's equal to, so 176 divided by 3, I have 58.66666. Alright, so that's equal to, my result gives me 58.666. Now what you observe is this: when it comes to tabular measurements, it's wise to always leave your decimal places as given in the table. So if I look at my table here, I have only whole numbers here. Alright, since I have only whole numbers here, my result is actually 58 points. Let's say 58.67. So that's equal to 58.67. So this is my value. But the thing now is this: if I go back to my table here, observe that in your table, all your values here are in whole numbers. All right. So you can't be having whole numbers here and then you now use a two decimal place system in your table. That would not be very correct. So what I would do is this. I will try to convert all the values in my table to one decimal place. And I'll do that by just adding dot zero dot zero. So I've converted this all of this now to one decimal place. It makes it easier for me. Right. Convert all of this to one decimal place. So I have this dot zero dot zero dot zero dot zero dot zero dot zero. All right. So I've successfully converted all of this to one decimal place. So hence I can put this value here in just one decimal place. In one decimal place, this is approximately 58.7. So that's my value. That means the mean for the small beaker becomes 58.7. All right. So this is my value. All right. So I've gotten the first one there. Let me now get for the large beaker. So for the large beaker mean, number two, for the large beaker, this is equal to, for the large beaker, what do you get here? Let's go back to the value of the large beaker. Large beaker here, we had the measured values from 1 to 3 as 58, that's this, 58.0, 59.0, and 58. So it becomes 58 plus 59 plus 58 divided by 3, since I took 3 readings. So that's equal to 58 or 58.0, same thing, plus 59 plus 58, of course, all divided by 3. So divide all of this by 3. So I have divided by 3, and that's equal to, so 58 plus 59 plus 58, that gives you 175. So that's equal to 175 divided by 3, and that's equal to 58.33. In one decimal place, that becomes 58.3. So I have this. All right, so my value becomes 58.3. That's my value. That's the mean, 58.3. All right, let's now look at the last one there. That's the small conical flask. Let's get mean for small conical flask. So number 3, get for small conical flask. For the small conical flask, we'll have that the mean is equal to, so back to this. All right, so for small conical flask, we can see that we got our measurement as 73, 74, and 73. All right, 70, so it becomes 73 plus 74 plus 73. All right, so let's get that done. 73 plus 74 plus 73. I'm having 73 plus 74 plus 73 all divided by 3, and that's equal to, so what do I get there? 73 plus 74 plus 73, that's equal to 220. That gives us 220 all over 3. And if you punch 220 over 3, 220 over 3, that gives us 73.3 in one decimal place. So in one decimal place becomes 73. So 73.3. So that's our result, 73.3. Okay, so let's come back here and put in the value for the mean as 73.3. All right. So with this now, we have successfully calculated the mean for each of them: the small beaker, the large beaker, and the small conical flask. Our next task will be to fill in the column of the percentage error. That's this column here. So let's try to fill in this column. How do we do that? First things first, when we say percentage error, what do we mean? So what do we mean by percentage error, and how do we find percentage error? That's where we start from. All right, let's take percentage error. So my next task now is to find percentage, that's B part here. Let's look for percentage error. Now here's what to note, please. How you solve this is this. Note that percentage error, your formula for this is equal to true value, that's your formula here, true value minus 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 observed value all over true value all multiplied by 100%. All right. So this is the formula to get the percentage error. All right. True value minus observed value all over true value times 100%. So let's start with the first instrument there, which was the small beaker. So let's start with the small beaker. Let's get percentage error for small beaker. And the percentage error will be equal to, let's start with the true value. So how do I get the true value here? Go back to your table there. Note that all the values here in this column are your true values. All right. So for your small beaker, the true value is actually 60. This is the true value for small beaker, that's 60. So I'll simply come here. It becomes for small beaker is equal to 60 minus observed values. For here, I have three observed values. All right. My three observed values are 59, 58, and 59. All right. So, and I can't use all three values. So I have to use one. The one value you have to use becomes your mean. So use their mean instead. So your observed value becomes their mean, which is 58.7. So it becomes 58.7. So this minus 58.7, 58.7 all over true value. So all over true value. True value we said is 60 for small beaker. So all over 60 times 100%. All right. So let's solve this. So this is equal to 60 minus 58.7. So if I do that math, I have my value as 1.3. That becomes 1.3 all over, my denominator there is 60 times 100%, and that's equal to, so 1.3 divided by 60, I have this value multiplied by 100, and that's about 2 points. 1.3 divided by 60 times 100% gives you about 2.17. But since I'm using one decimal place, I'll just use 2.2%. So my answer becomes 2.2%. So the answer is 2.2. If you punch that to the calculator there. So for the first one there, which is your small beaker there, the percentage error is about 2.2. Of course, you don't have to put percent again because you already have percentage here. Alright, so you don't have to put percent there. So that's just 2.2%. Okay, so let's get for the large beaker. And of course, since it's also in one decimal place, of course. So let's get for the large beaker. Large beaker, let's get percentage error for the large beaker. So example number 2, let's get for the large beaker. So for the large beaker, that's equal to, let's get the true value. We said the true value is the value in this column. This column here, this one here. Right, this is the value for the true value, the column for the true value. For large beaker, we also have 60 as the true value. So I'll come back here. the true value becomes 60. So that's equal to, I have here as 60 minus, for the observed value, I will take the mean. So for my large beaker, as you can see this table here, the mean of the large beaker is 58.3. That's this. All right, so that becomes my observed value, 58.3. So minus 58.3. I'm having 58.3 all over, so all over true value, which is 60. That's 60 times 100%, and that's equal to, so let's see what we get here. 60 minus 58.3, I have 1.7 there, so that becomes 1.7 all over 60 times 100%, and that's equal to, so if I do 1.7 divided by 60 times 100, that gives me 2.8%. So I'm having here as 2.8%. All right, so I'll take this result, I'll go here under the large beaker, for the large beaker row, I had 2.8% as my answer. So I'll come here and write 2.8%. So 2.8, of course, is in percentage there. All right, so I have 2.8 as my value. Finally, let's get small conical flask. Let's get for small conical flask. So number 3 there, small conical flask. 1, 2, 3. Small conical flask, and that's equal to, let's get the true value, the observed value, and the true value. For small conical flasks there, you can see that the true value is this one here, which is 75. So it becomes 75 minus observed value is the mean here, 73.3. So it becomes 75 minus 73.3. So that's equal to 75 minus 73.3 all over true value, still 75. That's all over 75 times 100%. So that's equal to 75 minus 73.3. That gives us 1.7. So I have 1.7 all over 75. So all over 75 times 100% times 100%. That's equal to 1.7 all over 75 times 100. That's about 2.3%. That gives you 2.3 in one decimal place. So 2.3%. So my answer here is 2.3%. So I'll come back to my table and fill this as 2.3%. Alright, so with this now, I am done filling this table for experiment 1, measurement of volume. Please, if these were not your exact values, now what I mean is that if you did not get things like 58, 58 here, 59, 58, 59, 58 here, it doesn't mean you're wrong. Okay, so use your own values as you got when you did your experiment, then solve with this pattern. All right, these values are just being used by me to illustrate how you can fill up the mean and percentage error. It doesn't mean you should start changing your own values. No, whatever values you got here, just use them in your own solving. All right. Okay, so let's look at the next thing there, the B part there, which is the measurement of weight. All right. So let's look at measurement of weight.